we'll get kicked off here today. Wanted to thank everybody this morning for joining Rumsey's ongoing webinar series, typically hosted by Rumsey specialists. However, in this particular case, we have a guest speaker from Senqcia, Steve Egbert. My name's Sean Huber. I'm one of the automation managers here at Rumsey. And today we're going to talk about, or I should say Steve's going to talk about, the environmental products in the power transmission realm that his company represents, and some of the time savings and longevity and benefits of what they do with their products in the environmental space. So with that, Steve, you can definitely introduce yourself better than I can, so I will turn this over to you. And feel free to ask questions, everyone. We will at the end of this, we will be sending out a PowerPoint presentation and some links and a copy of the video, just so everybody's aware from a notes standpoint. Take it over, Steve.
I appreciate that, Sean. As Sean mentioned, my name is Stephen Egbert, and I have spent my entire adult life, teen life, and probably the very end of my preteen years in chain, believe it or not. And I'm not sure why I did that, but I'm still in it, and I'm a lot older today. So my background, as I said, is it's close to 40 some years, over 40 years in chain, with several years selling wastewater products for Sabaki, and the last 11 years selling wastewater products here for Senqcia. It's not my only responsibility, but it is one of my major responsibilities. And I am the regional manager for Senqcia for the eastern half of the United States. So it's a pretty big area, and I've been to a lot of wastewater facilities. And one thing that I will say that I found over the last 11 years is that while the processes or the goals of each wastewater facility are all the same, to purify the water to a certain degree, they all have their own nuances, their own way of doing things. There's no one main blueprint to follow. There's concepts, and then there's variations of those concepts. So it's been quite a learning experience for me along the way, but one that I think has benefited me in the long run. And I'd like to share some of that information, what we do as an organization, and what we think helps improve the products that are in rectangular clarifiers primarily, although we do make a few products for circular. But I'd like to cover some of those products and just briefly go over some of it. I know I'm pressed on somewhat on time, and I have a lot of slides, so I'm going to try and advance through this. Okay. Again, the wastewater treatment plant applications, typically the bar screen, which is where the influent is, the grit collection, primary clarifiers, secondary clarifiers. And if you look at a schematic, if you will, of a wastewater facility, this would be basically what it looks like. From my products, which are the chain and the sprockets and the other products in a clarifier, you'll find what we offer in the Headworks, which would be the bar screen chains, and those can be unique to almost every facility. Some sort of larger chain that can be 6 inches, 4 inches. Some have buckets, believe it or not. Some of them have bar and screens in there, and a lot of different styles, but they all do the same thing, which is to take out the bulk products, be it rags and things that fall through in some of the facilities. As you know, up north, there are many dual facilities, meaning they don't just take waste from buildings, residences, and businesses. They take the runoff from highways. And in those highways, you can get a lot of products that fall off of trucks and blow out of the back of pickups and that sort of thing that work their way eventually into the Headworks. And that's where that area is key and important, to take those big, large products out. And then, of course, the primary clarifiers are where you'll find the bulk of our products. So I'd like to start there if I can. And this is a typical 4-shaft rectangular clarifier. Nothing fancy about it. You can see that there are usually typically a 2.609 pitch chain. It's either plastic or stainless that is driven here. We carry both. It's an EPC type or an NH78 or an NH78 stainless steel. It's an 11-tooth sprocket that is driving it. And then this sprocket can be usually anywhere from 45 to 54 teeth is typical range for that sprocket. And it drives, of course, this shaft, which is the driving shaft. And of course, it'll push through this direction, and I'm going to show you where the sediment would build up in this area on the top, and then where the sludge and that sort of thing kind of collects in these troughs down here. And I'm going to cover that in a little bit later in more detail. But this is basically what it does. It just pushes the products, whether it's greases, oils. Sometimes you'll find some solvents in there, and other things that settle on the top of the water, and that is pushed along in one direction, and it is accumulated, and then it is oftentimes collected in a scum pipe, if you will, and then removed. And I'm going to show you the scum pipes a little bit further down the line. The bottom, or the sludge, these can have a base. I've been in the Tampa wastewater, Hillsborough County, Florida, where they've had over 3 feet of sludge on the bottom. And of course, they measure it just simply by putting a pole down there, putting a thumb on top of the pole and pulling it out and taking a look at how deep the sludge base is. Not scientific, but nonetheless accurate. So when you have that kind of buildup in some of the larger cities, you have to, you realize that as you move the chains forward, they have to move at a very slow rate of speed, or it's only going to kick up the debris, and they'll end up floating through the mid area of the tank, only to settle back down later, if they ever do. So you have to move this chain very slow. You'll see it runs about 3 feet per minute, so you can imagine how slow that is. And it takes this product, again, as I said, it brings it into this basin here, where it is accumulated. There may be several tanks side by side here, and they'll have another set of chains, another set of scraper bars or flights, if you will, or they might have a screw conveyor all down in this area here in the lower left that takes the product that's been accumulated from the sludge from the bottom and takes it out for further processing. So that's kind of the concept of the purification for the rectangular clarifiers. What we offer in a typical rectangular clarifier, is everything that you see in here. And that's quite a lot of product. It's not just the chain. Most people just think of the chain. They'll think of the chain with the attachments. They'll think of the flights. But there's other products in here as well. A lot of them are wear shoes that you'll see that protect the fiberglass flights. There's HMW wear strips in which the flights slide, so you reduce friction. We do the wall brackets, which simply is a support mechanism for the wear strip to support the flights. We have the sprockets, and the sprockets, of course, are usually 17, 19, or 21 tooth. I don't think I've seen anything bigger than that on the idlers. Those are typical. Of course, we also offer cast nylon idler shafting, or we call stub shafts, in replacement of the old corroded shafting that goes across, and whether it's 18 feet, 16 feet, whatever it is, across the entire tank. Those aren't necessary any longer, and they oftentimes create more weight in the process, a little bit more drudgery, if you will, to turn the actual mechanisms to push the flights. So therefore, the power consumption can be quite high, can be costly over time, especially when municipalities are oftentimes trying to reduce their costs. You also see the wear shoes on the bottom, wear strips. Again, that's where the flights rest. On those, there is a wear shoe and a floor shoe, or a return shoe and a floor shoe. Those are important because that's what slides on the UHMW, again, to reduce the friction so that everything slides nice and easily, and that there is not resistance. And that's the key behind all this, is to offer products that can handle the loads of a 3-foot bed, if that's the case, and it's not often the case, but if it is the case, at a slow speed, without damage, without breakage, and then changing and reducing the loads from the old cast irons that you used to see out in the field with redwood flights and how heavy those used to be. Those are no longer necessary. So again, this is what one typically looks like. Again, this is another version of it, just another this is an actual installation that we've been involved in where we put in our chains, our flights, the cast nylon stub shafting, and some of the nylon wall bearing, which I'm going to talk about, I believe, I think it's the next slide. So again, these units over the years have been cast iron. And they offer corrosion. I'm going to skip to the next slide and then come back to this. But what they have a tendency to do is over time, once they're exposed to air, in other words, if we have a problem with the application of chain brakes, of flight brakes, and something happens, or heaven forbid, something falls into the tank and creates a train wreck, if you will, as they call it often in the industry, then they have to drain the pit and fix everything. And of course, that's kind of problematic. And when you do that, you lower the water or you reduce the water or you get rid of the water entirely, you end up creating the oxidation process. And this is what you end up with. Again, once you expose the steel products to the air. With the nylon products, you don't need to do that any longer. And all we do is simply replace those. They mount right into the wall in the same way that the cast irons did. Again, this is the old cast iron, but this is kind of what it looks like. It's mounted into the wall, and then we've eliminated metal to metal. We've eliminated metal to plastic. Everything that we do is plastic rotating with plastic. UHMW, which is the ultra high molecular wear type of products that are very, very, very smooth and offer the best resistance to friction. And so all we do is press that. As you can see here, this is what the bearing would be. It's pressed onto the shaft. So in other words, we bore it out to the sides of the shaft. We often measure the shaft. We might have to clean up the shaft if there's corrosion on it, but that's simple to do. And we simply bolt it onto it or press it onto it. And then this product, the yellow sleeve, as you see, simply spins on the plastic housing. That's what rotates, the plastic yellow, and along with the shaft as they are attached or pressed together. And then the plastic spins on the plastic, and that saves a lot of problems in cases where you see this, where you have the lead babbitt. Again, lead, and you have the iron housings, you have a steel shaft, all of those which are heavy, bulky, corroded, oxidizing, loud, noisy, and they weigh a ton. And those are just not practical in today's facilities. So we offer these products as an alternative and have been for many years. When you talk about it on some of the on the idler side of things, again, if you wish to keep the sprockets, if you want to keep the shaft there, that's not a problem. We have what we call a static shaft bearing, which really all it is a two-piece construction sleeve with a flange on it. That's all that the flange is there only to keep everything in line. But again, it is bored out to a press fit onto the shaft, bolted together. The idler sprocket, let me see if I have that on the next slide. The idler sprocket then simply rotates on the yellow plastic shaft. So you have a plastic sprocket rotating on the plastic shaft of the plastic sleeve, and there's no metal to metal rotating. The idler shaft no longer needs to do anything. It can sit there and look pretty, if you will, or look ugly, as they often do, and just have it fixed on there while the plastic sleeve does the turning, or excuse me, while the plastic sleeve does makes as the makeshift shaft, if you will, and let the sprocket simply spin on the OD of that sleeve. And again, metal to metal is eliminated. There's none of that heavy, bulky, grinding sounds. The plastic idler sprockets simply rotate as the chain is pushed at a 3 foot per 3 foot per foot, or 3 feet per minute rate. Again, this is just kind of what it looks like. This happens to just be the black plastic version. We have white and black plastic. I'm not sure. There is a difference in there. One absorbs UV and one doesn't. And sometimes the ones that are at the higher end of the closer to the water level are often black plastic, just because they do not absorb the, I can't remember if that's the way that is, if it's black or white, but one of them absorbs the UV rays and the other does not and resists it. And so whichever one it does, we put at the top end, and the ones that are at the bottom is usually the ones that don't have any effect of the UV. Again, replacing shafts. This is pretty common. I was just at the actual yogurt facility, believe it or not, in New York State, where they replaced all of their shafting in their tanks, and they only had 2 of them, but they replaced everything. And one of the items that they put in was this one here, where very simply put, it just is where you, instead of having the shaft that has to go across all 4, you would replace the idlers, not the drive shaft, obviously, but the other 3 shafts where you don't need the big bulk, you don't need the iron, you don't need all that problem. You can simply put in a stub shaft. It bolts on to the end. The stub shaft actually is cone shaped, but there is a shaft that comes out at the very end. You can't see it in this picture because it's inside the sprocket, but it is bolted and secured on. And then, of course, the sprockets sits on it, rides on it. You can see how it's locked in on the edge, and it simply turns at the rate of speed that the chain travels, and there is no need for any shafting. It is a great product. One that, again, when facilities are opting to make changes or when facilities are opting to make upgrades, this is typically the direction they'll go. In some cases, they don't have the financial abilities to, so they'll keep the old shafting and they'll use the products I just previously showed you. But in the cases when they can, and in some businesses, they may be able to do that more so than municipalities, this is often the direction that they'll go. One of the most key components that we offer in a rectangular clarifier is the chain and the flight combination. That is obviously, the chain is the backbone to everything. The flight is what does all the moving of the products. And of course, what you see in here is a filler block. You have to have a filler block because the flights are C channel type, so they look like the letter C. This takes up the space that's inside here so that it bolts up nicely to the attachments. I'm going to show you some things we do with the attachments in a little bit, but I do want to point out to you that all of our linkage, all of our screws, nuts, bolts, washers are all 316 stainless. So there's no chance of them oxidizing, period. They're never going to rust. They're just the 316. So what we do here is we have wear shoes, we have the return shoes and the floor shoes, and just both styles. I'm sure you understand what they both do, but the concept behind them is to protect and to make ease of sliding the flights along the support rails and the floor strip, as you saw in the previous slides. And of course, the return shoe has the flange, and that kind of keeps it from wandering left and right. And that's all that really does. We offer it with a little special indicator in here, what we call a wear alert indicator. And so what happens is typically when a maintenance person is walking around and inspecting or giving a visual inspection of the clarifier, they'll look down, and this component that is attached to the flight might be just under water level. And when it's a solid color, as you saw here, black, in some cases blue, if it's like a polychem or something like that, they start to wear in a pattern, and they wear in a little 3-inch section right in the middle of the attachment. And it starts to concave, but you may not be able to determine how much of that protective shoe is worn, because it's hard to get a depth perception while walking around the perimeter. And so what we've done is we put a wear indicator. And what the wear indicator is as the shoe reaches a 50% wear point, you start to see the beginnings of the yellow. And it gets larger as you get to 60, and as you get to 75, it gets full size. And at that point in time, it's telling you visually, as you walk around the perimeter, this shoe has reached its limit. Now, the key behind that is if it wears through completely, the fiberglass flight will slide on the UHMW track. There are other obstacles, if you will, that can contribute to the cracking of the flight. And it's just like a windshield of your car. You can start off with a rock hitting it, and you get a little tiny hole, and then the next morning you go out to your car and it's the length of the whole windshield, a crack. And that's what happens with the fiberglass. And that creates a problem because that component can break. It can splinter in half. It can fall into the product. It can do a lot of damage when it goes around the sprocket. So this prevents all of that. I like to call it a small insurance policy is really all it is, because it's for the little that it is an upgrade. It can save you thousands and thousands of dollars in there. And I want to talk about the fiberglass flights real quick. And of course, they come in two sizes, 6 inches and 8-inch height, pretty standard. We have a standard duty, which is the most common. But as I mentioned to you, there are some facilities, usually the larger cities, where they might, New York City or somebody like that, and again, down in Florida, where they get a heavier bed. They might have to increase the size and the thickness of these flights, because not only do the flights have a tendency to bend in the center, especially if you have a 20-inch wide or 20-foot or 18-foot width tank, they start to bend, but they'll also start to lift. And when they start to lift, they put a tremendous strain on the attachment flights themselves, and that's where they will often crack. And I'm going to show you that where they crack in a future slide, but that's often the case, and that's what happens. And of course, it always happens at night, and it always happens when you're minimally staffed, and it also happens when you are on holiday. So that's typical. The high strength also gives you a longer width, 22 feet. Now, I've never been involved in one that's been over 20, but I guess that there are going to be some that are going to be a little wider. And so, again, we can cut these to length for you. So if you have a 16-foot, 9-inch width, not a problem. We can cut it to 16-foot, 9-inch, or typically a small, an inch or two less than the overall width is usually what we'll do. And of course, we have the heavy duty. Again, this is for tanks that are up to 37 feet. Again, I've never been in one or seen one that's been that wide, but I do say that we have extreme duty when you have a heavy bed at the bottom too. And that is the case in where you have like Tampa, Florida, where they have the real heavy base. We also have aluminum flights, and this is an actual facility that is replacing all of their flights with aluminum. And I always say, I don't think you necessarily need to do that. I mean, if you got the money, you can do it. But the nice part about the aluminum flights is that they can take one hell of a load, and they do not bend and all of that stuff that the plastic or the fiberglass is subject to. So where you have, again, when you're into larger cities where they have a huge influent, where they have a lot more contaminants that come into the facility, they are often the ones that have the bigger beds. And so they have, that comes under load, because you can see there's a load that's going to be applied to every single flight. So again, this is an option that we offer. It's easy to install. They're just bolted in. Again, this is all 316 stainless on the linkage in there. It bolts into it, and you can slide it anywhere, and it's easy to take out. And when you're done with them, you usually sell them for scrap. You usually just don't toss them out. You usually can sell them, and somebody will come up and pick up. They pay for it by weight, and they'll pick it up from you. So that's that. It all you can recoup some of the expense from the aluminum flights if you do it. What I often say is, if you're in a situation where you have a heavy bed or you've had flights breaking, it's probably best to look at the heavier duty fiberglass ones. But if you're in a real situation where you have an extremely heavy bed, or you have a long facility that has a lot of load on it, where the tank might be longer than 150 feet, it could be whatever the length may be. The aluminum flights are good to put in where you might only use 4, equally spaced throughout, because that can help alleviate some of the tension that the chains will fall, or the other flights will come into. So again, it's something that is used in spacing. It is often used to help in heavier beds. And again, if you have some facilities like New York City, again, of course, or Boston, or even Los Angeles, where they have a lot of tanks, then they might use this in some of the ones, especially in cross collectors, as I mentioned, where you have the feeding of side-by-side rectangular clarifiers, and they go into that trough. Well, you would oftentimes, that's going to accumulate a heavier bed, And so they'll often use the aluminum flights in some of those in some of those troughs where they call them the cross collectors, where they're going to scoop out a heavier load from a shorter distance. They often will put these in. So again, and they're all stock as well. And again, this, you can see how, again, when they put the plastic on here and so forth. I'd like to talk about the chain because, as I learned over the last 11 years, not all of these chains, just like industrial chains, are not created equal. And they have different components, be it material-wise or dimensionally. And they often, if not always, I'm not sure about always, but not often, will they ever intercouple. So one manufacturers will not intercouple with another's. And when you do that, there's often warranty voids in these chains because of it. But what you have here is we have a nylon reinforced pin. In other words, it's kind of like a fiberglass, where it gives it the pin only, a hard surface. It's kind of what I would say is similar to like heat treating the pin, if you will, if being in plastic. You need a rough surface there, or a hard surface there, because that is a wear point. That's what the chain wears. When that starts to get smaller and smaller, the chain starts to elongate, it starts skipping sprocket teeth, and you have problems because one may pop a sprocket tooth on the right side, but the left side may not, and then you have a misalignment of the flights as they go around the sprockets, and that's going to be problematic. And I don't have to tell anybody here how problematic that can be. So, and also the wear. The ultimate load, the working load of a chain is based on a formula that is pin diameter versus the length of the bushing, which are the inside link, if you will, times the compression resistance of the material. So in other words, when you change the compression resistance of the material, you give the chain a higher workload, which means it can handle a heavier amount of sludge on the bottom without having problems, without wear. And that's key to this whole situation, the whole chain process. So again, we use a nylon reinforced pin, but we also keep the plastic other components of the chain, the polyacetyl plastic or the acetyl resin. And that's because that chain needs to be durable. That needs to be flexible, because that's where the load, as we mentioned, as the flights go through the thick base of the rectangular clarifier, you could have thick beds, and it may not only just bend and make it kind of like a bow shape, but it can also lift it. It can lift it upwards. So you have the bowing and the lifting, and that creates an awful lot of torque right on this part of the chain, and that's where the chains always break. So to be durable there, or to be forgiving in that area, is very key to longevity of the chains. So you need it to be a hard part where it's important to be a hard part, which is the pin for wearability, but you need it to be forgiving, flexible, durable on the other components, where again, that's a call for a longer lasting chain. So again, we tell you about the components. All of our products, test over, they all have to have a rating of at least 600,000 pounds on the ultimate strength, which is the breaking point of the chain. If you were to take 6,000 pounds and take 3 links and pull them apart, 6,000 pounds, they have to surpass that to meet the minimum. Well, ours are usually around 8,400, I think. I think it's for 8,500 pounds. And again, the weight is only 1.6 pounds per foot. So getting away from that old cast iron stuff, then you don't need those. Those would be 7-8 pounds a foot. And again, of course, when you're talking over 150 foot or 125 foot length, and then of course you have the return, which is another 125, 150 foot of weight, and then you have the other side doing a duplicate. It can be really, really expensive. So the non-metallic 720S chain is the way we build it is. Again, it's a big deal. We're showing you a couple of the competitors. There are some differences in the styles of them. You can see what they are, but I think the most telling part, I'm going to show you this in a minute, some of the things we do to the chains. We always feel that there are, I've got 7,500 pounds. I thought it was 8,500 pounds. Ours is 7,500 pounds. But nonetheless, it exceeds what's required by a substantial amount, and a lot of that has to do with the with the nylon reinforced pin primarily. And again, that's important to do that. And there are some things, again, where we talk about, again, the flexibility of some parts. This is what our pin looks like. This is what a competitor's pin looks like. Now, ours is pressed in. We do not use a clip. Many companies, if you talk about it, if you want, and this is a polychem chain, but the difference here is that you can see the difference in the diameter. And as I mentioned, pin diameter contributes to the formula of increased workload, and again, of course, the ultimate strength as well. But so to have a smaller pin diameter will be less effective when you have the heavier beds and wear faster, just because the load will be applied to a smaller surface, and that smaller surface is going to be continually forced on with the loads, and that's going to create a problem much quicker than you will when you have a larger pin diameter. Again, there's the polychems is clipped. So the clip has a problem. They used to be a dark blue. I think they've gone to a white pin now to make it more noticeable, because what happens is if products like rags and that sort of thing get past the influent or the water screen type chains, they often have a tendency to hook onto those clips. The clips are rather large, but if the clips fall off, or if the clips aren't installed properly, if something happens, there's a vibration that you have in the chain and through the process, they often work their way loose. The pin is slip fit. In other words, it's not held in there by the press fit as ours is. There's a slip fit. It's like having a connecting link. It'll eventually, with the vibrations, work its way out. And it'll work its way out, and the chain will come apart, and then you'll have a problem, and what you end up getting is a chain, what they call a train wreck. And again, those always happen at the worst time. They never happen when the facility is staffed properly, on a Wednesday afternoon in the heat of the workday. It's always a terrible time. And so we feel that pin creates more problems, and it might be easier to install. You only have to install them. We give you the chain already pre-assembled. You don't have to do anything with it. The only thing you have to do is put the 10-foot or 20-foot sections, I think, is what we give you together, and one every 20 feet. So these clips here, they're every link. We feel that they're problematic. They often come apart, and the reason that they changed from dark blue to white was because they recognize that the problem exists, and that this is their way of helping you make more of a determination when you do your visual inspections around the perimeter of the tank. But they're not all caught, because when you do your perimeter inspection, a link deep down below the water level or the visual level may have a missing clip, and you wouldn't know it because the speed of the travel of the chain is 3 feet per minute, as we said, and that might be, a couple hours or whatever it is, and we can do the math before that comes around again for you to notice it. So it's problematic for use. Something we do again a little differently. Again, I was mentioning that chains have a tendency to break at this attachment, and they'll break at this point here. It's the 90-degree point at which the attachment leaves the chain and goes up to the attachment itself, the F226 or the F228. And of course, that's where the flight is bolted onto. And again, as I showed earlier, not only does the chain bend or the flights bend, but they also lift. That puts a lot of torque here. This is very narrow, and that's what breaks. It cracks and breaks, and that's the end of it. And then, so the chain itself is only as good as its weakest component. This is its weakest component. This. And so we change ours to make it a much wider, much more beefier, much more forgiving, much more durable, much more whatever you want to say, whatever other adjectives are out there for it. But again, it is a key component to the longevity of the chains. Again, wearable pins, key to the longevity. Forgiving material, key to, again, longevity, and a much wider flight attachment portion here, where the attachment leaves the chain at a 90-degree angle, and it's a 90-degree angle where it's going to crack always. That's much more forgiving or much more durable. So again, we feel that component is much better. And again, this is what they end up getting. I should have gotten rid of that Hitachi Next Generation. Sorry about that. But this is basically what will end up happening. And the parts fall, the components break, and next thing you know, they have to drain the tank, and it becomes a nightmare. And of course, they have to divert the water, the influent, to another tank that's been, maybe to the left or to the right or somewhere else in the facility. And they have to go and fix this. And of course, that's nobody's dream job. So again, everything that we try to do in our components is to avoid this. Again, some things we do with the chains. Again, we always inspect. We always look for voids. There's always these things that you cannot always tell by eye, but you have to test them. We have to quality assurance. You have to do all those things. We do them because if we supply New York City with all of their wastewater, and not only with their wastewater chains, and not only do we have to inspect it all, but we also fly them over to our facility where they're being made for their inspection upon their request. And we also have to be able to trace the materials from start to finish. So there's a lot that we put into our products. And that's New York City's requirement, and they're about $3 million a year. So it's important to do these things. We have the capabilities to do all of that. And that's just showing you, again, part of the inspection process. This was an actual chain. I don't think I'm allowed to tell you who the vendor is, but it was a cheap vendor, a cheap chain who produced this process or produced this chain. It's funny because we lost this job. This was down, I believe, in the Georgia market, and we lost the job on price. But I always say, well, I can understand that because 1/3 of the product is air. And so, I guess, when you have that kind of problem in your production, you're going to have a cheaper product. And again, when you do inspection, if you do 100% inspection, you're going to find that because it's not going to handle the pull test. It would never make it through the ultimate load testing. It wouldn't. And I just showed you what the ultimate load testing was. That's what it is right there. So you pull it. Well, this would crack. This would break in a heartbeat. So when we got the chain, when they asked us to take a look at it, we split it and we found out there's these things called voids. And again, that's just impurities in the process. It is a defect in the manufacturing process. I'm not saying every chain that comes out from that manufacturer comes out this way, but because of the process, when you don't do quality inspections, this is what will happen. So again, you have to do the quality inspection because these chains will break. And again, we do the sprockets, split sprockets, are very common, especially when you're not going to replace the shafting, you're going to leave it in there, and you're going to put in the sleeves and that sort of thing. We do it a little differently with ours. We do what we call a spin casting on there. The spin casting, when you pour the plastic in its liquid form and into the mold, and the mold is spinning, what happens is you get a little thing called centrifugal force that pushes all the plastic outward. The concept behind that is to eliminate, just like you saw that is on the chain, which is the voids, which is the air pockets. And when you do that, it's just putting pressure in there. So again, I always say it's in a simplified form for me to understand it. I always say it's like hardening the teeth of the plastic, if you will. It just gets rid of any of those defects that lie beneath the surface that you can't tell. But the process is the process. And when you buy the sprocket, knowing that it's produced correctly. Again, this is just, the way we make our sprockets. We actually put in a couple of different materials because some of them have to be, this material has to be, is the spin casting, but this is a little bit harder because when you have a keyway in there, this material has to be a little bit harder so that the keyway itself doesn't start to, I want to say, it becomes misformed, I guess, if you will, or becomes worn or becomes oblonged or whatever, has Weirs parts on it. So again, we kind of make our sprockets in this fashion where they're durable at the teeth, and again, they're durable at the keyway, and that's important because that's where those parts are going to wear. Again, this is just showing that, again, this is the same material we make our pins out of, which is just a glass reinforced kind of thing, like a fiberglass. And then these two materials don't connect together. That's why we put the polyurethane in there, because that is bondable to both materials. Where this is not bondable to that, this polyurethane is bondable to both. That's why that's in there. And again, this is basic Sprockets 101. You know, when you want to have a better sprocket, you put a larger length of the bore in there. Again, it just gives you more area to take load and apply load and force, that sort of thing. So again, it's more important to have that, and so we recognize that. And you might find that our sprockets have a little bit longer of an LTB than our competitors. Now, theirs might be cheaper, but it's going to show up in its performance. And of course, we have this is a dual drive system here, as you can see. So there'll be a tank to the right and a tank to the left being driven. And I think I showed you early on in the schematic where we had the 11-2 sprocket. Well, that's what these are here. The 11-2 sprockets, and down there is the one where you have the 54 or 45, 54 tooth. And again, this is the plastic version of the chain. And what you're seeing here is some, you have jaw clutches on here. So if there is a resistance somewhere along the way before the chains start to break, this will slip. It's just a slip clutch kind of thing where it'll come apart. Therefore, it'll just spin and move freely, as opposed to trying to force its way through whatever resistance is there. When it tries to force itself, that's when things break. So this is a measured slip clutch kind of thing. We use snap eilers for our tensioning devices. I'm going to show you why we feel it's a little bit better, and this is what it looks like. And it's designed for the width of this chain, but this is typically what you've had over the years, is you have a point here where you have an eiler, and it pushes in on the chains so that you get a certain percentage of wrap, at least half. And usually you want to get half wrap on the drive sprocket, so that's what it's trying to do here. But it just creates another surface where you're going to, again, where the chain wears, because the chain wears anytime it bends. It wears here, and it wears here. It'll wear here, but it's slower because it's a bigger circumference. The snap eiler doesn't have that issue, where it's going to provide the half wrap with less of a tensioning area, less of a bending area. And the nice part about that, and I want to see if I can get to the right one, as the chains start to wear, they get longer, they get sloppier, and they get looser. And as they get looser, this plastic piece starts to slide downward. When it gets to the level of the floor, when the top part gets to the level of the floor, it's time to replace the chain. And so you can't determine that when you're using just the sprocket style or something like this. You can't tell. It's just going to keep pushing it on, and it's only going to be able to put so much tension on. But with this, as it slides downward, gets below the concrete level, you now determine that this chain, the life of the chain is coming to an end. Again, it is a preventative step, so that you can visually inspect the chains and get an idea of when you need to replace them, or when you're coming to the end of them, or some chains maybe they take a week to get to you, that sort of thing. So again, that's important. This guy put the idler on the wrong side of the sprocket, so they actually had it on wrong with an idler shaft. Oops, I don't want to do that one. With our snap idler, you don't have that problem. So what they did on that other was they pushed it from the outside or from the inside out, and that creates a problem. That's not going to give you any tension. That's an actual usage, by the way. That's an actual picture that we caught. We also have stainless steel chains. We sell stainless steel to the big cities, again, whether it's Boston, New York, Los Angeles. We don't sell it to Tampa. Minneapolis and some of the bigger cities, they use a stainless steel chain. Those are warranted. I think those are warranted for, I think they're 15 years. Of course, we go back and inspect them, and I think this same chain that was back here in '85 was only replaced one time. So I think it was, and that's only recently. And again, here's the stainless steel chains. We saw the plastics, but we also carried in stainless steel. Again, that's just for heavier loads, so you don't want the elongation. And this was the Scum Pipe I was mentioning to you earlier. They used to be, or they're often found to be, and I want to show you that. They're cast iron like this. And again, when you drain the pit, that's where you get all of this rusting, oxidation. Now this is a lever that is used to tilt. As the chain pushes the scum to this direction, as you'll see here, it pushes it to that direction up to the pipe. they take the pipe and they simply tilt it, and all of this gunk falls into it, and it's swept away. And so that's what you get. Well, this is what it's replacing. This is expensive. They're awful. They very seldom work because they corrode. With ours, again, ours is plastic. You don't have any issues. It's gel based on the inside. It's actually gel based, and it's tapered on the inside so that as the scum gets in there, it's angled away and goes to wherever it's going to be discharged from. This is what they look like. This one was a big one. This one was 40 feet. That's obviously that's not typical, but this is one we built for somebody 40 feet. And this one was going to use a screw, a worm and a worm gear. And up top here is a big handle that they just simply turn, and this tilts. We also have them where they're done automatically on timers. We have an overload. I shouldn't say an overload. We have a flight monitoring system. So all it does is puts two feelers on the very edges right before they come to the sprocket in case, as I mentioned to you, if one link on one side skips a sprocket tooth, that means the flights are going to be misaligned. If they're misaligned at the slow travel speed that they offer, let's say 2 seconds or 1.5 seconds, whatever the setting is, the flight monitor will detect that, and it'll shut the system down. It'll flash a light. It'll do whatever you want it to do, send a signal, buzz a horn, do whatever, and it'll tell you that there's a problem, but a preventable problem to keep from catastrophic failure, and that's always important. And of course, we have the weirs and baffles. I do find these in some of the rectangular clarifiers, more so than I thought I would, but they are out there, and they're just basic. But you see them a lot more in the round tanks, and they just have a basic process where it lets out the clean water and it keeps the dirty water, and there's a pipe or some kind of collecting device. Usually it's a pipe that'll come by and or a skimmer will come by and it'll push it into a pipe or an opening, and that's all it kind of does. But that's really all it does. They're fiberglass. They used to be aluminum. Aluminum corrodes. They're awful when they get like that. We use fiberglass, and they still last you forever. They really do. That's kind of the concept. That's what they look like when they are aluminum. They get ugly. Be fast. And so that's pretty much it, guys. There's really not much more on it, the presentation, than that.
All right. Well, thanks, Steve. I guess with that, I know you went through a bunch of pictures, and actually, Steve, you had showed that to us ahead of time. I definitely appreciate all the pictures and pieces that are part of the system. But I guess just open it up. Are there any questions anyone would have as far as the products or concepts that Steve went over?
Steve, this is Dave.
Hey, Dave.
On your stub shafts, are they sized obviously by the shaft size, but then the bolt holes, are they sized for the particular shaft diameter bearing, if you will?
Yeah, they're going to be sized based on the shaft diameter that's going to be on that little extension part that you really couldn't see. But that's exactly what they'll be.
So if you have a 2 7/16 square bearing and you get a 2 7/16 or a wall bearing and you get a 2 7/16 stub shaft thing there, that will bolt into that bolt pattern?
Yes, I find that people often will relocate that a little bit. I think that's more desirable. I think the one illustration shows that, where you can clearly see the old wall mounted unit where the outline was and where the new one was placed was slightly a little bit down and to the right.
Okay.
So you would put a new one in, would be what you would most likely do.
Thank you.
All right. Any other questions?
I couldn't have done that good a job explaining this. There's got to be questions. I'm like it. Okay.
Don't sell yourself short, Steve.
All right. Well, listen, if there's anything, I know it's a lot to digest, and I know there's a lot in there. So if there are If there's other questions down the road, or if anybody has something specific they want to talk about, or if anybody has an application that you want to discuss offline, I'd be more than happy to discuss that with you in deeper detail.
Yeah, no, that sounds great. And yeah, with that, we will be sending out a recording of this along with some of your supporting information, Steve, so everybody will get that. We'll make sure that the contact information is part of the follow-up here to everybody that registered and is on here.
Okay.
We should be good.
I appreciate it, guys. Thank you very much for your time. I appreciate the opportunity to present the products to you.